So here's the first example. It says that you borrow $1,000 at 5% simple annual interest. Compute how much you owe after 6 months, 1 year, or 5 years. Well, I'm going to start with some language. So first of all, the amount borrowed is the principal. I'll find a pen that works here. So the amount borrowed is the principal. So P equals $1,000, which is the principal. 5% is the interest rate, and we express that as a decimal when we do the math. So my interest rate is 0.05, and that's the annual interest rate, so how much you earn in 1 year. And then it says compute how much you owe after. Well, the amount that you owe after 6 months, 1 year, or 5 years is called the future or maturity value. So this is the future value or the maturity. Oh, squish my Y in there. So, or the maturity value. Okay, so lots of vocabulary terms. Well, let's just figure it out. So if I was looking to figure out what the interest was, the interest would be how much I borrowed times the rate. So it would simply be P times R. So let's do A first. So 6 months. So for 6 months, I'm going to take, let's see, the interest is the principal times the rate, but remember that rate is in annual interest. So I need one more piece of information here. So if I do P times R, that would be 1,000 times 5%, which would give me the interest for an entire year. But I don't want the interest for an entire year. I want the interest for half of a year. So I'm going to put one more value here so that we can use it for any amount of time, and that's T. This is the time in years. So the time in years. So 6 months is half of a year. So we're going to change that into 1/2. So times half of a year. And I've just got my calculator off to the side, and I'm just going to type in 1,000 times 0.05 times 1/2, or you can divide it by 2. And we end up with an interest amount of $25. But the question says, how much do you owe after a year or after 6 months? So if I want to know how much I owe, what I owe is the amount that I borrowed plus the interest. This is my future value. Okay, straightforward, right? But we've got some vocabulary terms to cover. So the future value, the amount I owe, is the principal, which was 1,000, plus my interest, which was $25. So I now owe $1,025. Okay, let's do the next one. B, after 1 year. So now T is equal to 1. Let's just skip right to that future value. So I'm going to write FV to look a little more technical than O. So my future value is principal plus interest. And that's going to be principal, which was $1,000, plus my interest. That's principal times interest rate times the time in years. So now I just take that 1,000, and I'm going to add 1,000 times 0.05. So I owe, and it's what you should expect based on your last answer. Now we owe 1,050, right? My interest doubled because I'm not doing half a year, I'm doing the whole year. There's no compounding with simple interest, which means we don't take the interest and add it back in and then pay money on the interest or earn money on the interest. Okay, there was a third part to this. C, the third part was 5 years. So my future value, or the amount that I owe after 5 years, is going to be my principal plus my interest, which is the original 1,000, plus the interest in 5 years. So 1,000 times 0.05 times 5. Think about what you have right here. I should get 5 times the interest. So 5 times 50, that's 250. Let's confirm that with the calculator. So my principal of 1,000 plus, just calculating this off to the side, 1,000 times 0.05 times 5 years, and that's exactly what I get, $1,250. Well, we can generalize what we have here. Each time we were doing, for that future value, principal plus interest. And if I take a look, I have that $1,000 here and here. If I go up to the example above, there's that principal. It shows up twice. It shows up in the principal and in that interest calculation. So if we want to generalize what we have into a formula, so this is our future value formula. We know that the future value is principal plus interest. And if you want to do it using this formula, it works perfect. But there is kind of a prettier looking formula, I guess. And I'm going to show that to you. So principal plus interest is principal rate time. I can factor that P out. And if I factor the P out, P divided by P is 1. PRT divided by P leaves me with the plus R and the T. So here is sort of a cleaned up version of the future value amount, or the future value formula. Either one though, so either this one or the other one, it doesn't matter. Here is another example. So keep these formulas in mind. So this first one says, there it focused. Okay, so this first one says you borrowed $500 to buy a gift for your favorite math teacher, of course. The annual interest rate is 6%, and you have to pay the loan back in 10 months. Find the future value, which is the maturity value of the loan. Okay, so $500, that's P. My annual interest rate, 6%, that is R, so 0.06. I have to pay the loan back in 10 months. This is T. But remember, T is the time in years. So that's 10 months out of 12, which would be 10/12ths or 1/6, or however, would it be 1/6? Divide by 2? No, it would be 5/6. However you want to reduce that, hopefully correctly. So 5/6 of a year. Find the future value of the loan. Okay, I'm going to use that new formula. So the future value is principal times 1 plus RT. Think about what this formula does. The future value takes the principal and it multiplies it times 1. That gives you the amount that you borrowed. Plus, it adds to that a multiple by R and T. This gives you the interest. So this is the original amount, the 1, and the R and T is the interest. So for our problem, we have $500 that we borrowed for that awesome, amazing gift. 1 plus 0.06 times, I'm going to use a little asterisk, 5/6. So in my calculator, I'm going to very carefully compute that. 1 plus 0.06 times 5 divided by 6, parentheses, and we get a future value, turns out nice, of $525. So after 10 months, you're going to owe $525. Don't overthink this. You're not making payments. So if it said you're making payments every month, it would be a way more complicated problem. You just have 10 months, and at the end of that 10 months, you're going to walk in and pay the entire amount. So we're going to keep it simple. Next example. Okay, so next example. You are hoping to have the $50,000 down payment for a house you plan to purchase 10 years from now. You plan to invest a lump sum from an inheritance in a savings account that earns 4% interest. How much do you need to invest if you don't add anything to it? Again, we're keeping stuff very simple. Okay, $50,000. This is how much we hope to have in the future, 10 years into the future. This is my future value right here. There's my future value. In 10 years, there's my T. You're going to put this into a savings account in a lump sum. Here's your interest rate, 0.04. How much do you need to invest? So that means that we don't know what P is. Question mark. That's my unknown this time. Okay, where's our formula? Future value is the principal times a 1 to get the principal added in there, plus an RT to add the interest in there. What do I know? I know that the future value is going to be $50,000. P I don't know. 1 plus r, which is 0.04. T, I do know that is 10. So if I do the 1, I'm going to do those parentheses, 1 plus 0.04 times 10, I get 1.4. So this is 1.4 times P equals 50,000. We're going to do a teeny tiny bit of algebra. We're going to divide both sides by 1.4. So P is, that initial lump sum that you're going to invest is $50,000. $50,000 divided by 1.4. And it says that you need to start off with $35,714.20, I'll say 29 cents, in that savings account now at 4% interest to have $50,000 10 years down the road. Think about it. It's just going to sit there at 4% interest, which is okay interest, but not great, 4% interest, and it's just going to sit there and earn about $15,000 over 10 years. Next, we're going to talk about what happens when we're not looking at simple interest. So most interest is not simple interest because banks like to make money. They like to compound interest and charge interest maybe every month and then add the interest into your account. So here is the compound interest formula. I'll give you the formula, and then I'm going to tell you what each of the variables represent. So the amount in the account, or the future value, is equal to the principal. And then in parentheses, remember with that parentheses, we need a 1, because that's going to add the original amount, plus, this is going to do the interest for me. So plus, I need to take the interest rate and divide it by the number of compoundings. So R divided by N. So I take that interest rate. If it's quarterly, it's 4 compounding. Semi-annually, it's 2. Monthly, it's 12. But I need to do this multiple times. Do 1 plus R over N for the new principal each time. So we end up with a power here, and that power is N times T. Your book describes it a little bit differently. I don't really like their formula that much, so I'm going to use my formula because I can. So I like my formula better. They use an M here and an N here, and don't put the T in. So I like to have the T in there. Future value is the future value. Let's see, what do we have new? That's still 1. That's still the principal. This is still my annual interest rate. N is the number of compoundings per year. That's the number of times they add the interest back into your account. Number of compoundings per year. T is still the time in years. Okay, so with that in mind, here comes an example. Let's see, do you still have that up there? Okay, so here we go. It says you take out a loan for $5,000, so there's my P, to cover tuition and other school expenses. The annual interest rate is 3% compounded quarterly. So R equals 0.03. Quarterly means 4 times a year. Quarter, so 4 times a year. So R equals, N equals 4. What is the amount of the loan plus the interest? Another way of saying this is the future value after 2 years. So now I've got T also, time in years. So my future value, loan plus interest, is equal to the principal times 1, that adds the principal back in each time, plus R over N, 0.03 divided by 4. Remember, 0.03 by itself is only for simple interest if it wasn't compounded. Still an annual interest rate, so we spread it out over 4 quarters. That's why we divide it by 4. All to the N times T, so that's going to be 4 times 2. So in my calculator, again, really, really carefully, so that I don't mess something up, I take 5,000, parentheses, 1 plus 0.03 divided by 4, parentheses. I'm going to call that 8. If you didn't call that 8 and did the multiplication, you'd need parentheses around that also. But I'm just going to do to the 8th power. And my future value then is 5,307.99 cents. So after 2 years, 3% interest. I started out with $5,000. I am up to $5,307.99. Not bad, right? Not bad at all. Did I do that right? Yep. Okay, not bad at all. What's the future value of the loan? Oh, except you owe that money. Maybe that is bad. What's the future value of the loan in 10 years? So the only thing that changes here is T changes to 10. So now I take for my future value, 5,000, 1 plus 0.03 divided by 4. I haven't changed the number of times I compound per year, still quarterly. What I change is how many times I do that over the course of this 10 years. So that's going to be n times t. So 4 times 10, 10 years. So now I'm going to multiply in my calculator all of this to the 40th power. So I'm going to change that to the 40th power. And now I owe 6,741.74. I don't know if you're paying attention, but this grows, since it's compounding, a lot quicker than simple interest grows. Every 3 months, every 1/4 of a year, they figure out the interest and add it back in, and then they're going to figure out the interest on that amount, so it grows pretty quick. Part C, what is the future value of the loan if the interest is now compounded monthly? So I'm going to change n to 12 times per year for 5 years. T is equal to 5. So my future value is $5,000 loan, 1 plus, I divide that 3% over the compounding periods. There are 12 of them. All to the n, which is 12, times t. Okay, that power is how many times the compounding happens over 5 years. So what is that, 60? 60. Okay, so in my calculator, 5,000, 1 plus 0.03 divided by 12, all to the 12 times 5, which is the 60th power. And we end up with a future value after 5 years of 5808.08. Okay, next example. So here's another example. You take a loan over for your son. So your son borrowed money, now you're going to pay it off for him. The maturity value on it, this is the future value, is 3,379.48. It was at 3% interest, compounded semi-annually. What n would that be? Semi-annually. So that would be twice a year. So n is equal to 2. What was the original loan amount? So that means that I don't know what P is. I think I left off one important piece of information, and that was the T. So the maturity value is this, 3% interest compounded semi-annually. And we'll say that the age of the loan is, let's say that it's 2 years old. Okay, so the age of the loan is 2 years old, which means that T equals 2. In my formula, I'm going to write the whole thing up here, 1 plus R over N all to the NT. I know what the future value is, so we just took over his loan, and the value right now, which is the future value, is 3,379.48, so that amount. I'm looking for P. I don't know what the original loan amount was for. 1 plus 0.03 divided by the number of compoundings semi-annually, so 2. All to the n times t. So those compoundings happened 2 times 2, so 2 times 2. So that's going to be a 4 up there. So as I do my calculations, I've got 1, I'm going to do this right here first. 1 plus 0.03 divided by 2, and I'm going to raise that to the 4th power. So I end up with 3,379.48 equals 1.06. I'm going to keep a bunch of decimal places for a minute. 1.06136 P. Divide both sides by 1.06136 to get P by itself. 1.06136. 3379.48 divided by 1.06136. And that original loan amount, P, was about 3,184 and 10 cents. So that was the original loan amount 2 years ago. So in this case, we were given the future value of that loan, and we had to go back and figure out what that principal, which we also call the present value. So we had to go back and figure out what the principal or the present value was. The very last topic that we're going to cover in section 14.1, and there are a couple others, we're not going to cover all of them. The last topic that we're covering in 14.1 is the effective annual yield. The effective annual yield, also called the APY, which is the annual percentage yield. Banks and credit card companies are required by law to report this. So if you look at your credit card application or a credit card statement, they have to provide you this, in addition to the nominal rate. Those are the cute rates that don't have any decimals behind them. So the nominal rate would just be the stated, or kind of like, I like to think of it as the simple interest rate, if we didn't have compounding involved, so the simple interest rate. Well, let's do an example. I'm going to do an example so that you can see where the annual percentage yield comes from. What we want to do is we want to take the stated rate. In my example, it's going to be 5%. Okay, so you invest money, and usually these show up on credit card loans, but you're going to invest some money, 5% interest. I want to know what the annual percentage yield is if I compound it. Well, if I'm compounding it, I'm not just earning 5%, I'm earning more. If you think about a credit card, if you take out a credit card and you have 20% interest, but you don't pay off your balance every month, so they're going to add your interest and your finance fees back in, and they're going to charge you interest on the interest, you're going to be paying way more than 20%. You're going to be paying the annual percentage yield, or the effective annual yield. You're going to be paying what that compounding gives you in the end. Okay, so here's an example. Okay, is it focused? Okay, so here's our example. If you invested, I'm going to do it for $1 so you can just see how it affects, just a really simple example here. $1, that's P, at 5% interest, so R is 0.05, compounded quarterly, N is equal to 4. What is the effective annual yield? Well, you know what I'm going to do? I'm just going to figure out what my amount is, what my future value is after 1 year. So in 1 year, because I want the effective annual yield, so the effective annual yield. So in 1 year, my future value is principal, which is $1, times 1 plus 0.05 divided by 4, all to the 4 times 1. So I'm going to grab my calculator. Thanks to these ones, all I really need to do is that piece. So I'm going to do parentheses 1 plus 0.05 divided by 4, parentheses, all to the 4th power. And we get 1.0509. So if you take a look at what you have, let's subtract a 1 from there. Remember, I started with 1, so if I subtract out the principal, I end up with the interest, which is 0.0509. So if I subtract out the principal of $1, what I have left in the decimal is the interest. So that means that I didn't earn just 5% over the course of that year. Because of compounding, I earned 5.09%. Well, if you take a look at our steps to figure out the annual yield, we did that compounding interest formula for $1 and 1 year first, and then we subtracted the $1. So our effective annual yield gets computed this way. 1 plus, we don't need that one, right? That was $1. 1 plus rate over number of compoundings, all to, I only needed the number of compoundings because we're looking for it annually. And then I subtracted off that dollar minus 1. You can do it either way. You can do it for any amount of money and then subtract the original amount of money to figure out what your annual yield is. I love it when people understand the process as opposed to memorizing a formula, but I'll leave it up to you. The next one I'll do with the formula so that you can see how the formula works. The savings account pays a nominal rate of 4%. That 5% up here was the nominal rate. We're looking for the effective annual yield. So R is 0.04. It's compounded monthly, so N is equal to 12. We're looking for the effective annual yield. I didn't write annual in there, but that effective annual yield means that we're using T equals 1, and that's why T doesn't show up in this formula, T equals 1. So the effective annual yield is 1 plus 0.04 divided by 12, all to the number of compoundings, which is 12. And I'm going to subtract out that original dollar to figure out what the interest is. So 1 plus 0.04 divided by 12, parentheses, to the 12th power, minus 1. When I do it all in one fell swoop, I get 0.0407. There's more decimals, 415. I'm going to leave it there. So about 0.0407 or 4.07%. So this is the APY, the annual percentage yield, or the effective annual yield. Now there's some questions about